Oh, hello, Mr. Lee here. So our next couple of weeks are going to be centered around linear functions. Okay, so we've started talking about functions, but now we're going to go back to lines. You should have already studied that last semester, and we're going to talk about it in the context of these functions. Okay, and more specifically, we're going to start seeing two or more functions and compare them. Okay, so all of your previous knowledge should still be applied, right? We're still going to use slope-intercept form, so you need to be able to graph lines using slope-intercept form. Also, identify any slope, any y-intercept of a line. Okay, as you start comparing these. So let's get started. This is going to be a tutorial on your on today's exercise. So this is called compare linear functions. We have two functions that we need to compare, right? We can't compare unless we have two or more things. So function one is defined by this equation. We should have a slope of 7/2, as you see, a y-intercept of -3 if you know your slope-intercept form. And then it says function 2 is defined by line f, right? So they label line f here on this graph. So very important to note, these are two different functions, okay? The first function has this equation. The second function has this graph, which will have its own equation, right? And we want to compare. Okay, so let's go down to the question, which function has a greater y-intercept? So all we got to do is figure out what both y-intercepts are, answer which one's bigger, and then there's our answer. Okay, so this one should be a -3, right? My y-intercept for the first function is a -3 because it's given in the equation. And then if I look at my second function, again, this is a different function. I have a y-intercept over here of also a -3. Okay, so they actually end up being the same, right? So we're comparing two different functions. Let's go ahead and find the one where it says the functions have the same y-intercept. Okay, neither one is greater, they're the same. Boom. Let's do maybe one or two more here. Okay, so function one is defined by the table. So you can have graphs, equations, tables, those three representations. This time we have a table versus a graph. And again, there's two different functions. So read this carefully. We have our table for function one, and then let me minimize this a little bit, and then our graph for function two. And our question at the very bottom, which function has a greater y-intercept? Okay, so let's compare the y-intercepts again. To find the y-intercept in a table, we know that the x value is always 0, or your input is 0, okay? You're going to start seeing different letters, right? It's not always going to be x and y, but as long as you know you have inputs on left, outputs on right, then you can still mix and match, okay? So my x value, or r value in this case, is 0. We know that we're going to have a y-intercept of 1, right? Visualize it on the graph. Whenever you're on the y-axis, you always have an x value of 0, and then the y value move up and down. So this y-intercept is 1. And then we also have on this graph, again, it's a different graph, also a y-intercept of 1 as well. Okay, so this is actually the same. We have the same y-intercept. Okay, let's see if we can do one more, maybe get some variation here, see something a little bit more interesting. Okay, so function 1 is defined by the equation y equals -2t plus 6. So again, some different letters, but you can still follow the general format of y equals mx plus b, right? Whatever's in front of your variable on this right side is going to be your slope, okay? And then we're comparing it with a function 2, which is this graph, and our question is, which function has a more negative slope? So instead of y-intercepts, forget about y-intercepts right now, we're talking about slopes, okay? So we're going to extract the slope value. This slope value is -2. And let's figure out what the slope value of here is, okay? So to find your slope, as a review, you can pick any 2 points and figure out what the change in y is over change in x. So I'm just going to pick something down here. Let's pick that point and this point. 2 nice points. It looks like I go down 1 and right 1, right? So my change in y is -1, and my change in x is +1. I'm going down 1 and right 1. So if I simplify that, your slope is just a -1, okay? -1 divided by 1 is a -1. So let's compare these two slopes. Your first function has -2. Your second function has a -1. So which one has a more negative slope? That should be function 1, okay? More negative means a smaller value in the negative, but bigger in its absolute value, okay? So -2 has a bigger negative slope, so we'll say function 1. And hopefully we get that right. All right. So re-enter my Zoom if you need to ask any questions. I'm here to tutor, so please utilize me, okay?